In this first video of section 6.3, we're going to look at how do we know if something is a binomial distribution. So a binomial distribution is a distribution of random variables in which each trial has only two outcomes. We call them usually success and failure. So success being what we want to see happen and failure the opposite of that, or what we are counting or whatever it is. Independent. The trials must be independent, so knowing the result of one trial does not tell us anything about the result of the next trial, like flipping a coin, tossing a die, that kind of thing. Number. There are a fixed number of trials, which we call n. That's one of the parameters of a binomial model. The probability of success, which we call p, is the same initially for each trial. Now we're going to look at 5 different situations, and we'll see how these 4 characteristics play out in different situations, whether or not they are a binomial situation. There's a little acronym BINS that helps you remember these 4 characteristics. So the first one is determine whether, the instructions say determine whether the random variables have a binomial distribution. Justify your answer. So we're going to go through these characteristics. The situation here is we roll a fair die 10 times and let x equal the number of 6s. So what we're looking for is 6s on the die. So when we're looking at our binomial situation, we're saying that our success is rolling a 6. And our failure is that it's not a 6. Okay, so that's what, it doesn't mean that X doesn't represent, in this case, like what number did you roll? Did you get a 1 or 2 or 3 or 4 or 5, 6? What we're looking for is either 6s or not 6s. That's what makes it binomial. Okay, I, independent. We know that dice roll, it's a dice roll, so yes, it's independent. N, the number of trials, we said we're going to roll it 10 times. So n equals 10, that's a fixed number. And the last one is S, the probability of success is the same. So we have a p is equal to 1/6 chance of getting a 6 every single time. So this is a binomial distribution. So this, we can say that this is binomial with, n equal 10 and p equal 1/6. So this is a binomial distribution. The second situation, shoot a basketball 20 times from various distances on the court. Let y equal the number of shots made. So the binomial part is, we're looking, did you make a shot or did you miss a shot? So our success is make a shot, and our failure is miss. Now, I do want to tell you that success and failure are not a judgment type of a word. If we were looking for how many did a person miss, then miss would be our success and make would be our failure. So success isn't being a good thing necessarily. Success is just what we're counting or what we're looking for. I. This one's a little problematic, whether or not that each shot would be independent of the other. But for the sake of argument, we can sort of assume that maybe that each shot is independent. A lot of times when we're doing sort of a sports-related thing, we're saying that in the long run, you know, they have this probability of making of getting a hit, or this probability of getting a shot, and for the sake of that argument, we're going to say assume that each shot is independent. We could argue that point. So maybe we would disagree with that one. But let's assume, because there's actually something else that keeps this from being binomial. So assuming each shot is independent, why is this not binomial? Well, n is correct. We have 20, a fixed number of trials. But here's the problem. Right here is the S. It says to shoot a basketball at various distances on the court. We're not going to have equal probability of making the shot at various distances. A person might have a much higher probability of making a layup than a three-pointer, or a free throw than somewhere else just randomly on the court. So P is not the same for each shot. Okay. Number 3, or number C here. Observe the next 100 cars that go by and let C equal color. So checking our binomial. So is it color or not color? Well, it's not impossible for a car to not have a color at all. It turns out that there aren't just 2 options here. We're looking at the color, and there could be lots of different colors. So we don't have this is not binomial. We don't have a success being we're looking for one particular thing and everything else is the opposite of that. So this is just not binomial. D, draw 5 cards from a deck of cards. Let x equal the number of cards that are red. So we do have a binomial situation. We either have our success is that we have a red card, and our failure would be not red. Okay, independent. Okay, is each trial independent? Does the probability of one thing change based on the previous? Yes, actually the probability does change. So this is not independent. If we draw 1 card from a deck, the probability of getting a red on the next card changes. So the probability changes each time we draw a card. So that is violated. E, roll a die until you get a 6. X equal the number of times you roll the die. Okay, so we're looking for a 6. So we have a binomial situation where we either have success is a 6 and failure is not a 6. Independent, we've already established rolling a die is independent. Number of trials. We don't have a fixed number of trials. It says x equal the number of times you roll the die. Roll a die until you get a 6. So we have, this is the one that's violated. There is no fixed number of trials. It turns out that this is actually a geometric model, which we'll talk about later on in section 6.3. So when you want to check to see if something is binomial, you have to look for these 4 characteristics.